Good afternoon, students.
Good afternoon, ma'am.
So, we were discussing about Verilog models of various combinational logic circuits. Okay, almost we have completed our unit, but still I feel that we should have some little revision of this topic. Okay, we will start new unit from fresh morning, and so today we will have revision of this third module. Okay, that is a Verilog models of various combinational logic design. So I'll present my screen. So first tell me what you understood with this Verilog HDL. Okay? Till now, whatever we have discussed, okay, what you understood.
मॅम व्हेरिलॉगचा कोड कसं लिहायचं? व्हेरिलॉगमध्ये कुठले कुठले टाईप्स डेटा टाईप्स आहेत किंवा व्हेरिलॉगमध्ये आपण इन्स्ट्रक्शन कसं डिक्लेअर करतो आणि त्याच्यासाठी काय यूज करतो, त्याचे कुठले कुठले इन्स्ट्रक्शन आहेत आणि त्याला कुठले सिम्बॉल आहेत.
Yes. Okay. So that we have discussed. So again, we are going to revise this in this today's session. Okay. So first of all, what is Verilog language? That Verilog, it is a hardware description language. But before going for the description language, it was just the modeling language, which was used for simulation purpose only. But after that, there were various evolutions that were taken, and it was used for logic synthesis. That means what we are using nowadays, that was the improved version of Verilog language. Okay. So, but earlier, in earlier days, when that means in a 1984 or some in that days, it was just a simulation language or the modeling language one. Now, but nowadays, this Verilog language, it has become a one of the most commonly used language for digital hardware design. HDL, that is the one more language that we are using for digital hardware language. Uh, so, as we have discussed earlier, that there are certain differences between this Verilog and VHDL languages, and depending on that, it is used in some of the countries like Europe and other countries. On in Asia, uh, this that means depending on usage, it is used in various countries. Okay, so now this is whenever we are designing any system, that means whenever we are designing any chip, it may be FPGA, that is a field programmable gate array, or it may be application specific IC. It is designed in part using any one of these language. It may be Verilog language or it may be VHDL. And both these languages that combine structural and behavioral modeling styles. That means in both Verilog as well as VHDL, we have uh, modeling styles, that is the structural and behavioral modeling style. Okay. So here, now let us see how this Verilog is used. As I said, uh, every IC, okay, it may be FPGA or ASIC, it is designed using Verilog or VHDL language, okay. That means VHDL, which is similar to Verilog language, which is used for the hardware description. So here, behavioral modeling that could be done with some structural elements, and then we get a synthesis subset. That means we are whatever we have designed, that is translated into next list. Okay. Now for that we need to use certain compiler. That means we can have, for example, a Synopsys design compiler or any other compiler that can be used to get a next list. So similarly, in a Verilog, what we are doing, we are designing a uh, any system. That means whatever particular system or circuit that we want to design, that is written in a Verilog first, and after that it is simulated to check its functionality. Okay, so very rigorous checking is done uh, to get the functionality, because as I earlier said that we are not just writing a program, we want to implement that program in a hardware, and that is why there should be a rigorous checking of that functionality of that program, and that is done once we write a code in Verilog. And after that it is synthesized. That means netlist is generated. Okay, so whatever input and output ports that are written in the program, so depending on that, netlists are generated again in between connections. So for that, again net are generated. Okay, so that means here what we are doing, we are synthesizing the given program, and after that a static timing analysis that is done to check the timing. Okay, so the timing analysis is also done with this program, and then we get actually actual code. Okay, so this is the way how we are using a Verilog language. Okay, now let us see what are the different components that are present in a Verilog. Actually, we have discussed this earlier. So we can have concurrent processes in the Verilog. Okay, so that means that are behavioral type of modeling. Okay, so these can be executed parallelly. Okay, so now here we have two types of blocks. Okay, now first block, that is the initial block that we have not discussed earlier. Okay, initial block, that means it defines initial states of the variables. Okay, so and always block, that means whatever statements that we want to execute after certain changes are there in any one of the operands, then we are executing always block. Okay, so in each of these blocks there are certain sequential statements that are present. So depending on the code, we are doing certain execution. So for that we use certain statements. Okay, so that can perform standard data manipulation tasks. That means there we are using certain assignment statements, then if then statements or case statements. So that type of things that we are using in a concurrent processes. Okay, and these processes run until they delay for a period of time or wait for triggering event. So that means this will continuously go on running. Okay, so they go on executing all the statements till there is a delay of a certain period. Okay, now another type of component, that is a structure. Okay, so we can build a program from the model with IO interfaces. So whatever uh, earlier models that are present, from that we can connect uh, these models and get a Verilog program. So these models that may contain instances of other models. So as I said, so we can have some another model, and then we can connect it to get a actual system. So modules that may contain local signals, then it may contain certain uh, operands, so that may be present in that module. So these module configurations that are static and that all that run concurrently. Okay. So these are the main components. That means actually what we can have, we can use a behavioral type of modeling in which we are going for the program which will have uh, truth table type analysis. Okay, that means if we have any parameter that is changing from 0 to 1, what is going to happen? That will be seen in a behavioral type of modeling, and in a structural modeling, we can have certain different models, and depending on that, we can uh, build a system or build a program. Okay, so now we have discussed this in an earlier lecture that there are different types of data types in a Verilog. Okay, but the main data types that are two. Okay, and that is net and register. Okay, actually net, that means it is the connection between things. Okay, so it may be anything. Uh, that means from the input port to certain gate, or it may be from gate to the output. So that is the net. Okay, so they do not hold any value, their value. Okay, so they will, whatever input that we are giving to that input put, so that will net will have that value, and it will take their value from a driver such as gate or other module. It cannot be assigned in a initial or always block. So we cannot assign net in a initial or always block. And registers, that means reg, that represent data storage. Okay, so whatever data we want to store, for that purpose we can use a register. That means for the output port we are using register, while for the input port we are using net. Okay, actually net has again different types that we are going to discuss in the next slide. Okay, so here we have registers that hold their value until they are explicitly assigned. Okay, in a initial or always block. They are never connected to something. Okay, so remember that these are never connected to something. That means this is the output port only. It can be used to model latches, then flip flop, etc. And they do not correspond exactly shared variables with all their attendance of. Okay, so here registers that can exactly like a memory in a computer. Okay, so whatever we want to store, for that purpose we use registers. So here, as I said, we have two types of data types. Okay, so that means actually the signals that we have. So it is a net and register. Okay, so net, that means there is a physical connection between hardware and elements. Okay, and registers that stores value, uh, that are the registers. Okay, now the main difference between the net and register, that is whenever we disconnect it from the input, net will have no any value. Okay, that means it will not store any value. So there will not be any value present on the net, but otherwise uh, this registers that will store the previous value. Okay, so here whenever we are disconnecting net from the source, net will switch to high impedance. Okay, as there will not be any value that will present. So you can see in this figure, this net will switch to high impedance, while whatever is the value that is present in a previous state, that will be stored on a register. Okay, so here remember that registers that can store even if they are disconnected from the source, but while it is not the case in terms of net. Okay, so these nets, as we have discussed earlier, we have different types of connections. Okay, that is wire, then WAN, then SAN, then SOI. Okay, so wire, that means wire harness. Okay, SOI, that means WR, supply 0, and supply 1. Okay, so these are the different types of data types actually. So that comes under next. We have separately discussed about all these data types. Now, what is mean by wire? Yes. What is mean by wire?
Ma'am, it is used to represent the physical connection.
It is used to represent the physical connection. Okay, so here you can see that it is the wire where there is a physical connection between the two gates. That is the wire. Now, if it is a WAN, that means whatever ports that are connected to that wire, output of that wire will be uh, logical AND of the ports that are connected. Okay, so WR, that is will be, it will result in a logical OR. And supply 0, that means that wire that is connected to logic 0, or it is supply 1, that means it is connected, that port is connected to the logic 1. Okay, and then we can have try also, that means it is a try state, then try and try or try 0, try 1, and try register. These are also there, but now we are not using this in this US syllabus, so we are not going in much details about this. Okay, but otherwise we are using wires, then W and WR. So we will limit our discussion till these data types only. Okay, so but remember that net actually it is a one of the data type which is used in a Verilog, and in that again there are different data types that are wires, WN, WR, supply 0, and supply 1. Okay, and again try and try or try 0, try 1, and try register. Now, whatever data that is present in a Verilog, that has 4 values. Okay, now if you consider about VHDL, then it has 9 values. But in a Verilog, it has 4 values. One is 0, first one value, that is a 0, that means logic 0 value, or logic 1 value. Okay, so these are the obvious values. Whenever we are considering any digital circuit, we know that that circuit will have these 2 values. Either it will be 0 or 1. But besides that, it will have a Z value. That means output is tri-state. Okay, so output of that undriven tri-state driver. So that is the one case. Or it may have the value that is the X. That means simulator cannot decide the value. Okay, so don't care value or try unknown value. Okay, so that is the X value. Now this X value that happens when input is continuously changing from 0 and 1. Okay, so that means whatever wire that is connected, that is being driven to 0 and 1 simultaneously. That is the X value. So remember that Verilog has 4 types of 4 values data, that is a 0, 1, Z, and X. Okay. So here you can see that we have 4 valued data, that is a 0, 1, Z, and X. And whenever we are representing this data, so that is represented like if it is a binary number, so we use B. If it is a hexadecimal number, we use H. If it is an octal number, then we use O, and for decimal, it is a D. Okay. So here, if we want to represent binary number, then 6 apostrophe B 100101. Okay. So that means actually this is a 6-bit binary number. Okay. And these numbers, binary values that are followed, that are that is the number, actual number. Okay, so that is a 100101. Okay, now can anybody tell me what is meaning of this? 6 apostrophe H25. Akshay, Snehal, आपण जेव्हा डेटा रिप्रेझेंट करतोय व्हेरिलॉग मध्ये तेव्हा तो कसा रिप्रेझेंट करतो, तर इथला जे काही पहिला बिट आहे तो काय रिप्रेझेंट करतो, किती बिट म्हणजे पहिला जे डिजिट आहे तो रिप्रेझेंट करतो किती बिट तुमचा बायनरी नंबर असणार आहे, त्याच्यानंतर अपॉस्ट्रोफ आणि त्याच्यानंतरचा जो काही letter असेल that decides which type of number it is. Okay, so that means it is a binary number, octal, hexadecimal की decimal. Okay, so that will be decided with this letter आणि त्याच्यानंतर ऍक्च्युअल नंबर जो आपण रिप्रेझेंट करणार आहे तो येणार आहे. ओके, म्हणजे आता इथं काय असणार आहे, 6 दॅट मीन्स
बिट हेक्साडेसिमल
6 बिट. Okay, 6-bit binary representation of the hexadecimal number 25. Okay, so that means if you are going to represent this hexadecimal number in terms of binary, so then it should be represented with a 6 bit. Okay, so actually 25 means how much, what is in a binary? Binary मध्ये तो काय असणार आहे, 25 किती येईल?
मॅम 0010 and 0101.
0010. Just check it once again.
मॅम आपण हेक्स बायनरी मध्ये त्यांचे 4 बिट घेऊन करतो ना, मग 2चं
Yes.
0010 आणि ह्याचं 5चं 0101.
0010 0101. Okay, so now what we are going to do, we are going to represent this in a 6-bit only, so it will be 100101. Okay, so that is the representation of this number. Okay, now actually the main unit of the Verilog, that is the module. Okay, so now we are actually going to see how we write a module. Okay, so now what this is the module, as I said, it is the basic unit of hierarchy in a Verilog. So this module describes boundaries, that means the first thing that we write in boundaries that are decided with the module and end module. Okay, so whatever we are going to write, that will be in between these two keywords. Okay, in a module and end module. Then we have input as well as output ports. Then we are going to write behavioral or RTL code for that circuit. That means how actually our circuit is going to operate or how it is going to work, that is written with this behavioral or data flow code or a RTL code. Okay, now it can be single element or it can be collection of lower level models. Okay, that means suppose we want to write a Verilog code for full adder. Okay, so we can write it using a behavioral modeling. So that means depending on truth table, we can write a Verilog code, or we can use two half adders and one OR gate, so that we can represent that full adder with this the half adders and OR gate. Okay, so that means here we need to write a module for half adder as well as OR gate. Okay, so by connecting these modules, we can get a particular module for certain system, or we can write a single element. So in both the ways, we can write a program. Then after that, uh, whatever we are writing in a model that can be described as a hierarchical feature. Okay, so a model of models that can be decided. Uh, a model that should be contained within one level. Okay. Now again, one thing is necessary that whatever module name that we are giving to that module, it should be same name to the program where we are saving. Okay, how we are saving. So that means suppose we have the module name that is the fader, then it should be saved as a fader.sv only. Okay, so it is may happen that the multiple models that can reside in a within one, uh, but actually it is not recommended. Okay, so now actually we will see what is the basic structure of model. Okay, so here as I said that the boundaries for this model that are decided with a model and end model keyword. Okay, so in between this we are going to write the actual program. Okay, so model, after that name of the model. Okay, and then different ports that are written. Okay, so whatever input and output ports that are present in that system that are written. Okay, now while writing the these ports, we can write it as a input ports and output ports. But the Verilog convention says that you should write output ports first, okay, and then input ports. But why it is done? Because the earlier models that are present or the modules that are present in the Verilog that uses this convention. Okay, if you writing a single module, that means that you are not going to use anywhere. You can write input ports first and then output ports first afterwards. Okay, but if you are going to use your module in a certain another program, then uh, you have to write output ports first and then input ports. Okay, so make a practice that you should write output ports first and then input ports. ओके, तुमच्या प्रोग्राम मध्ये जेव्हा तुम्ही सिंगल प्रोग्राम लिहिताय, म्हणजे आपण जसं आधी याच्या आधी प्रोग्राम बघितलेले आहेत, हाफ ॲडरचं लिहिला किंवा फुल ॲडरचे लिहिले, जिथे आपण हे कन्व्हेन्शन नाही पाळलं कारण आपण ते कुठेही यूज करणार नाहीये. ओके, पण ज्या केसमध्ये तुम्हाला हे मॉड्यूल दुसऱ्या कुठेतरी यूज करायचे, इन दॅट केस यूज आउटपुट पोर्ट्स फर्स्ट और राईट आउटपुट पोर्ट फर्स्ट अँड आफ्टर दॅट इनपुट पोर्ट. ठीक आहे, हे जर तुम्ही लक्षात ठेवलं तर तुम्हाला कुठलाही मोठा प्रोग्राम लिहिताना that will be easier. Okay, so first use output port, then declare. Here we are just giving the names. Okay, so writing the names of these ports. So after that we need to declare whether it is the input port, output port or in output. So that declaration is done after uh, declaring the name of that module, and after that there will be certain sequential statements or execution statements that will be present and then end of the module. ओके, म्हणजे इथे आपण काय करणार आहोत तर कुठलं पोर्ट आपण इथे जे नाव दिलं, सपोज मी आउटपुट 1 म्हटलं, पण आउटपुट 1 काय आहे तर आउटपुट पोर्ट आहे. सो इट विल बी रिटन एज अ आउटपुट 1 अँड देन सेमिकोलन. यू कॅन राईट इट इन अनदर वे दॅट सगळे जे आउटपुट पोर्ट्स आहेत ते कॉमाने सेपरेट करून लिहू शकता अँड देन सेमिकोलन दॅट यू कॅन गिव्ह. And similarly, you can do it for the input ports also. Separate different input ports with a comma and then at the end give a semicolon. So that is the model. Okay. Now, as I said that we can have a Verilog model by instantiating a different modules. Okay. That means we can connect a different module, lower level module, and so that we can get a particular model. That means suppose I have a model, that is the model, my model, and then I have ports, that is the Y, A, and B. Okay. So here this will look like a my. That means now this can be used in certain another program as a my mod. Okay, and then here we can get the list of the uh, ports. Okay, so here now y2 a1 b1, so that means whatever ports that we are using in particular program, so that could be used here. Okay, so now in this case, now remember that मी जे आधी म्हटलं ते की आपण आधी आउटपुट पोर्ट आणि नंतर इनपुट पोर्ट डिक्लेअर केला, तर आपल्याला आता इथे होतं की इथे बाय डिफॉल्ट हे कळून जातं की माझा जो पहिला आहे ते आउटपुट आहे आणि त्याच्या नंतरचे जे आहेत ते input ports are. Okay, so here so that it will map that ports easily. So for that purpose we use write in that way. Now whatever are the gate level primitives that are used in a Verilog, that are and, then NAND, logical AND or logical NAND, then OR, NOR, logical or logical NOR. So these are the different primitives that are used in a Verilog. Okay, so or that are present. So here buff if 0, that means tri-state with low enable, then buff if 1, so that means tri-state with high enable. These are the different gate level primitives that are present in a Verilog language. Yeah. After that, again coming towards the common operators that are used in a Verilog. Okay, so this is a very important, because sometimes we forget which symbol is used for particular operation. So for that, this table it will very important. So if you remember this, you will get the idea how to use that operator in your program. So we have, suppose operator type, that is arithmetic. So we have different symbols. Star for multiple, multiply. Okay. So here we use two operands that can be used. Okay. So number of operands that are required for this type, that is a 2. Then slash, that is for divide, plus for addition, minus for subtraction. Okay, so these are the symbols that are used for arithmetic operations. Then for bits-wise logical operation, it is used tilde for bitwise negation or for complement purpose. Okay, then ampersand for bitwise and, vertical bar for bitwise or, exponential mark for bitwise XOR, and exponential tilde or tilde exponential for bitwise XOR. So the first tilde, that is a bitwise negation or complement, that requires only one operand. But otherwise all other that requires two operands. That means you need to have two operands to perform this operation. Then shift operation, that could be done with a greater than that two symbols that could be used for shift right, and less than, that is you can be used for shift left. Okay, so these are the different symbols for used for shifting operation. Then we have one more operator, that is concatenation. Okay, concatenation, that is used for replication of the data. Okay, so suppose we want to replicate any data, so that could be written in a curly bracket. So curly bracket, that is a symbol used for concatenation or replication, and any number of operands that could be used for this concatenation. Okay, and conditional operator, where the symbol is question mark and colon. Okay, so condition is written before the question mark, after that there is a question mark, then first expression separated with a if that condition is true, then there will be first expression. After that, if the condition is not true, then there will be a colon, and whatever expression that we need to execute, that will be after colon. Okay, so here for conditional operation we require three operands. One is for the condition, otherwise second one, that is if the condition is true, then there will be second operand, and if the condition is not true, then third operand that is required to be executed. Okay. So these are the common operators that we are going to use in this Verilog HDL. So the first, we have certain examples for this. Okay. So tell me, a plus b assign x is equal to a plus b semicolon. What this instruction will do? We have seen these different operators. Okay. So tell me now, we have the statement assign x is equal to a plus b semicolon. So when this instruction is executed, what will be the result? ISL result?
मॅम फर्स्ट का?
First, assign x is equal to a plus b.
मॅम ॲडिशन होईल. एक
Yes,
कंटेंट ऑफ ए प्लस कंटेंट ऑफ बी.
contents of A plus contents of B. So that is a simple addition that will be taken place. Okay. For the second instruction, assign y is equal to tilde x. That means
And not logical not
y,
operation is performed.
yes, y will be equal to x bar. So
Bitwise.
logical bitwise x not operation that will be performed here. Okay. Then after that, y is equal to a ampersand c.
Bitwise and operation is performed.
Bitwise and operation, yes. Then w is equal, assign w is equal to a exponential b.
Bitwise XOR operation is performed.
Y is equal to x greater than 1.
Shift operation is performed by 1.
Yes. Okay. Here, for whenever we have two symbols, greater than symbols, so that time right shift will be there. Okay. So that means x will be shifted by, to the right. Okay. And here, whatever value that is expressed here, by that much value, x will be shifted. म्हणजे इथे आता 1 आहे, तर x कितीने शिफ्ट होणार आहे? 1 ने शिफ्ट होणार आहे. If it is at 3, then x will be shifted with 3, and then additional zeros will be added at the uh, left place. Okay. So here, then the next is the assign y is equal to curly in a curly bracket b comma c. So what is meaning of this? Y will be combination or concatenation of B and C. So here the example is if B is equal to 3 apostrophe B 101, that means B is a 3-digit number, 3-bit number 101, and C is again 3-bit number 111. Then Y will be equal to 101 111. So that means we are combining these two bits, two numbers together, which are making this y of a 6-bit. Okay, so it will be 101 111. Okay, so now here we have the conditional operator that we have used. So here assign y is equal to s is question mark b colon a. So what is meaning of this?
It is again combination of full adder मध्ये आपण यूज केलं ना मॅम.
No, I am asking about 7th.
Condition ma'am. If S is 0, then assign B. If S is 1, assign A.
If here it will check for the conditional operation. If S is true, then it will assign y is equal to b. If S is false, then it will assign S is equal to y is equal to a. So that means whatever we are doing in a as to one multiplexer. Okay. So, that is done in a using this statement. Okay. So we have seen this expression for the 4:1 marks when we have written program. Okay. So the similar thing that we are doing in a conditional operator. So here we have the uh, another thing that we need to say, that is suppose we want to add a delay. Okay, so that could be added in a instances. So that is here, suppose we have the statement that buff, that is b1 a comma b. So that means there is no any delay. But suppose we have the statement buff hash 3 b2 c comma d. That means to execute this statement there will be delay of c. Okay. Now if we have the statement buff hash 4 comma 3, that means rise time is a 4 and fall time, that is a 5. Okay. And if we have hash 3 colon 4 colon 5, that means minimum delay is a 3, maximum delay is of 5, and typical delay, that is 4. Okay. So that could be stated in the in this way. Okay. So that means suppose we want to introduce any delay, so that could be introduced in this way. Now let us discuss about continuous assignment. So for continuous assignment, we use a assign statement. Okay. So here, whenever we want to assign or we need to have continuous assignment, so that time we use assign and then the with operands that are used. Okay. So here you can see for some we have used this continuous assignment. So whatever changes that are happening in the operands a, b and carry in, that will be continuously reflected at this sum. Okay, that at this output. So for uh, anything that we want to assign for the output, so for that we use this statement. Okay, this is the very convenient way to specify logical or data bus specification. So here we are using assignment statement. Or for the behavioral, we are using initial blocks or always blocks. Okay. So initial blocks, as we have not used in any program, so I have not discussed earlier, but still today I will discuss it a little bit. So if we are considering initial block, so we have to start with the keyword, that is the initial. Then after that we have to start that block, so begin, and after that there will be certain statements. Okay, and then end of this initial block. So this runs when simulation starts and terminates when control reaches to the end. So whenever simulation is starts, it will start its start this, and after that it will terminate when control reaches to this end statement. Okay, and we have another block, that is always. Again, it starts with the keyword which is always and then begin, and there are certain statements which are present and then end. So this again starts with whenever simulation is started. Okay, and if control reaches to the end, then again it starts with this from the first statement. Okay, so that means it continuously go on checking for whether there is a change in any one operand, and then it continuously executes that particular statement. So let us see example of this initial. So run until they encounter a delay. Okay, so suppose we want to have certain statements that to be executed till there is a delay. Okay, so hash 10, that means there is a delay of a 10. A is equal to 1 and B is equal to 0. Okay. After delay of 10, we have A is equal to 0 and B is equal to N and then L. Okay. So when it reaches to L, it will terminate. Okay. But otherwise, we have the another example that wait for an event. Okay. So in that case, we can represent this as a always at positive edge of clock. So post edge, Q is equal to D. Okay. So that means whenever there is a positive edge of clock, then Q will be assigned value, that is D. Okay. So here we have used single statement. There is a single expression that is present. So begin and end keywords that are not present. But we have, if we have multiple statements, then we need to use begin. So always begin, and then we whatever instructions that we need to execute, that will be present, and then end of that always block. ओके. म्हणजेच आता इथे काय होणार आहे, जेव्हा आपण इनिशियल ब्लॉक वापरतोय तेव्हा प्रत्येक 10 नॅनो सेकंडच्या डिले नंतर A will be having value equal to 1 and B will have the value that is 0. Okay. After 10 nanosecond, again A will have the value 0 and B will be having value 1. पण एवढं झाल्यानंतर तो टर्मिनेट होईल प्रोग्राम. ओके. पण जर आपण ऑलवेज ब्लॉक वापरत असू तेव्हा मात्र काय होणार आहे, क्लॉकच्या प्रत्येक पॉझिटिव्ह एजला Q विल बी असाइन्ड व्हॅल्यू ऑफ D. ओके. म्हणजे जी काही D ची व्हॅल्यू असेल ती Q ला असाइन होईल, किंवा इथे ज्या काही इन्स्ट्रक्शन्स असणार आहेत त्या सगळ्या एक्झिक्यूट होतील. ओके. म्हणजे ऑलवेज ब्लॉक मध्ये काय होणार आहे की परत तो रिस्टार्ट होणार आहे, परत तो तिथं जाणार आहे आणि ज्या काही इन्स्ट्रक्शन्स असणार आहेत त्या एक्झिक्यूट होतील. So if we have certain procedural assignment, okay, so that means we want to follow certain procedures. In that case, we use initial block or always block. Okay, so whatever statements that we want to execute in a sequential manner, that we write in a always block. Okay, so suppose we want to have the addition. So sum is equal to A plus B plus C. So in that case, we are using this initial or always block. So whatever we perform in a C, in the similar way, here also RHS is evaluated and then assign that value to LHS. Okay. So this now what this happens whenever or before the next statement is executed. Okay. So whatever value of the RHS that is assigned to LHS and then next statement is executed. Now these RHS that may be wires or registers. Okay. So that are the two possible sources of data for this Verilog. So RHS may be wires or registers, but LHS is always a register. That means whatever output that we need to calculate. So here that should be a register type one. So you have to remember that whenever you are having a statement in an always block. So while assigning this on the LHS side, it should be a register. So here, if we compare Verilog language to VHDL, then VHDL as compared to Verilog, it has this little bit wider scope. Okay, because system level modeling that is done efficiently in a VHDL. Also, it exposes more discrete event machinery. Okay, and then VHDL is a better behaved, but the disadvantage of VHDL, that is it is a case sensitive. It is advantage of this VHDL, that is it is not case sensitive, while Verilog is a case sensitive. But VHDL is a more verbose. That means we need to write complete statements in a VHDL. Okay, so here if you see Verilog program, it is a very simple. It is of a very less statements. Okay, so that is the advantage of Verilog language. So here we have discussed about whatever we have discussed earlier. Okay, so म्हणजे तिथे आपण फक्त बघितलं होतं की ते आपण काय करतोय, कुठे डेटा टाइप्स आहेत वगैरे. So I have summarized this in today's presentation. So I hope you have understood what is mean by Verilog and how we write a program. Okay. If you have any doubt, you can ask me. Still few more minutes are there.
No doubt, ma'am.
Okay. In the tomorrow's lecture, we are going to start with a new unit. Okay. Uh, let us have one test on second unit on Saturday. Is it okay with you? Or we will have it on Sunday. संडेला घ्यायची की सॅटर्डेला ठीक आहे. सॅटर्डेला आपण
मॅम
लेक्चरच्या टायमिंग मध्ये घेऊ.
ऑलरेडी संडेला टेस्ट आहे मॅम.
कशाची?
मायक्रो कंट्रोलरची सर घेणार आहेत.
ओके, सॅटर्डेला घेऊयात मग.
ओके मॅम.
और मंडेला आपलं लास्ट लेक्चर असतं ना, तेव्हा घेऊयात. विच इज कन्व्हिनियंट टू यू. Okay. In that test, we are going to write. Okay. So the questions will be based on just VHDL module. Okay. कुठल्याही एका टाइपने स्लाइड असेल, it will not be mentioned. So you have to prepare for all the circuits and that will be there. Okay. काही प्रॉब्लेम आहे का? So
नो
you
मॅम,
tell me.
म्हणजे कोडच असणार आहेत ना?
हा, कोड लिहायचे फक्त. And then you have to upload it in a Google form. ठीक है. So we will have it on Monday then at the last
Okay.
lecture, 3 to 4. Okay. So we'll stop here for today.